Hey guys, welcome. Today we'll be talking about how to create a YOLO-V6 model on custom dataset. For this, we are using this dataset. So here we have some images of dolphin and tortoise. So you can see this is an image of a dolphin here. Let's take another image. So yeah, you can see this is an image of tortoise. So download the dataset from here. So after download the dataset, create a folder that is YOLO-V6 training on your Google Drive. Then inside that folder, create another folder that is data, and upload all the images with annotations here. You can see we have images with annotations that we downloaded from this link. So after this, create another folder that is test images. So here we have some images to test. So after that, we have test output folder. So here we'll be saving our results on test images. So here we have another folder that is YOLO-V6 training results. Inside this folder, we'll be saving all the files that will be generated during training. And then we have our dataset.yaml file, then our training notebook. So this is the training notebook we are using here. So guys, for YOLO-V6 training, we are following a particular folder structure. So we'll be using all these images and annotations that are present inside data folder, and we'll be creating this folder structure. So here we have YOLO-V5 data, we have images, we have labels. Then within images, we have train, val, and test. So within train, we have all the images for training. Within val, we have all the images for validation. And here within train, we have all the annotation files for training images. And here we have all the annotation file for validation images. So guys, I would suggest don't create the test folder in this directory. Create a separate folder that we have seen here. You can see just like this. So this is the folder structure we'll be creating for training. So then import these libraries, then connect the Colab to your drive. So I have done that, and you'll be getting this thing. You can see this is the drive, and within that we have my drive. Then we have the YOLO-V6 folder. You can see, then data, test, all those folders here. So our Colab is connected to our drive. You can see here. Then to create this folder structure, you can see we are specifying the path, that is YOLO data, images, train. You can see here. So YOLO data, images, and train. Just a second. Okay, images and train, we are running this cell. After that, so guys, I have written this this function. So what it will do, it will take all the data from here, from this folder, and it will split the data into training and validation. It will create all these directories, and it will place the images file, all the images and their respective annotations in the corresponding directory. So if you run this command, you can see, so it is taking the data from data folder here. So this is the folder. It is taking the data from that folder, and then it is creating the training and validation split. You can see. So let's just refresh this one. You can see, so this folder is created here, and within that we have images and labels, and within images we have train and val. So it is creating this folder structure here. You can see, so YOLO data, images, train, and within train we'll be having all the training images. You can see we are having all the training images. And same thing within the label folder, we have train and validation folders, and within train we have all the labels that are for training images. You can see here. So now we have created our required directory for YOLO-V6 training. So you can see we have 1000 number of images, and you are using 800 for training and 200 for validation. So after that, open the dataset.yaml file. So it is present at this location. You can see within YOLO-V6 training. So drive. Okay. What I did. Okay. Okay. I clicked that thing. Okay. just okay. So it's fine. Let's just focus here. Okay, ignore all these folders, just focus here. So this is our drive, you can see, and within this drive we have my drive, then YOLO-V6 training, you can see here, and here we have dataset.yaml. Now inside this, put the path to training folder here. So this path we have to put like YOLO data, images, and train, you can see. So this path is present here. So within content, you can see we have we have YOLO data. So here we are having all the images, right? So within that we have images and train. So copy the path here and paste it here, you can see. So this is for training. Do the same thing for validation. After that, put the number of classes that we have. Here we have 2, and we have the class name as dolphin and tortoise, you can see. So put all this information and save the dataset.yaml file. Then after creating the dataset.yaml file, clone the YOLO-V6 repository. So here we are cloning the repo. Just okay. So it is cloned, you can see here. Let's refresh. So you can see we have the YOLO-V6 repo here. Then after that, we are changing the directory into YOLO-V6 folder, that is here. We are entering into this folder. Then here we are checking the working directory, you can see. So it's fine, we're inside the folder and the working directory is correct, you can see here. Then here we are installing all the required libraries that are needed for YOLO-V6, you can see. So it will install everything. Then after that, we'll be downloading the weight file from these links. So if you want to train YOLO-V6 large, go with this link. For medium, this link, and for small, this link. If you want to check the other weight files that are available on the YOLO-V6 GitHub repo, click on this link. So you can see we have different weight files that are available for fine tuning, you can see. So here we'll be working with the YOLO-V6 small model. So for that, copy the link and paste it here, and then run the command, you can see. So I have done that, and we have the YOLO-V6 small, you can see. So this is the YOLO-V6 small model we have just downloaded. So this is within the YOLO-V6 repo. And after that, to use this particular weight to do the training, open the config file that is present inside config folder and open this one. So we are using YOLO-V6 small, hence open this fine-tune.py file, and then put the directory for the weight that we have just downloaded. So our YOLO-V6 small is present at this location, you can see. Copy the directory, copy the path, and put it here. So this is the configuration file for fine-tuning the YOLO-V6 small model. So we have the similar kind of file for different model, you can see here. For now, we'll be working with this V6 small fine-tune file. So I have put the path to this YOLO-V6 weight file that we have just downloaded here, you can see. So guys, here if you check this file, you have different parameters to customize our YOLO-V6 architecture. We have, we can see optimizer, we have learning rate values, we have momentum values, we have all these parameters for augmentation. You can play with all these parameters. For now, I'll be just changing this path only. So save the file and close it. So after that, install this library. So I was facing some issues, like it was saying like this library cannot be found, hence I did that. So do install pip install addict. So after that, this is the code for training. So guys, before going into the code and do the training, let's go to the repo, you can see. So this is the repo of YOLO-V6. Go to the folder, so tools, and open the train.py. So here you can see like we have all these parameters which can be used to customize the training to have a better understanding or to have a better control over the training. So you can see we have data path, we have config file path, we have image size, batch size, epochs, worker, device. We have all these parameters, and here we have all these descriptions as well, you can see. So please go through all these parameters and the descriptions you can see here, and then go to the training. So here we are using this command for training, you can see. So we are using patch 8, we have image size of 640, we have epochs of 50, that is we are going for 50 number of epochs. Then we have config file that we have just modified, you can see here. Then we have part to our dataset.yaml here. Then device 0, if you go here, device, that is 0. So if device equal to 0, then we are doing the training on single GPU. If we have multiple GPU, if you want to do the training on multiple GPUs, we can put like 0 1 2 3, you can see here, or you can put CPU for doing the training on CPU. So after that, here we have like eval interval 2. So if you check here, eval interval, that is 2. So if you put eval interval 2, it will do the evaluation after each 2 epochs. So like it will do the evaluation after 2 epochs, after 4 epochs, after 6 epochs, and so on. So after that, here we are putting the output directory, that is this thing, like within our drive we have YOLO-V6 training folder, and within that we have YOLO-V6 training results. So if you go here, so we are putting the directory as YOLO-V6 training results. So here we'll be saving all the files that will be generated during training. So after that, we are selecting another parameter, that is name. So if you go here, you can see, so this is the name parameter, and it is saying like all the experiment names saved to output directory /name. So basically here, like we are using these two parameters, so output directory and name. So basically within that folder, this folder will be created, and within this folder we'll be having our old files and all the files that will be generated during training. So I have all these files because I have already completed the training. And then after that, we have like save checkpoint on last n epochs. So basically what it will do, let's say we are going for 50 number of epochs. So it will save the weight file, the best weight file, the last weight file, as well as the epochs, the weight file from the epochs 40 to 50, the last 10 epochs, just like this. So here I have gone for 50 epochs, and you can see I have weight file from the best weight file, the last weight file, and the weight files from 40 epochs to 49 epochs, you can see. So this command or this parameter will create all those weight files. After that, run the command and the training will be started. So you can see you will be getting output like this. So using 1 GPU for training, and this is the YOLO-V6 architecture, you can see. And then after that, after printing the architecture, so here we have the training output. So you can see, so this is the first epoch, that is 0th epoch. Then it is done. Then after that we have 1 number epoch. So after that we are doing the evaluation here, you can see. So after each 2 epochs, you can see we are doing the evaluation. So after the training is completed, you can see, so here it will go up to 50 number of epochs, that is 49th epoch, you can see. So here after that the training is completed, we have a MMP value of 0.79. You can see at 5, and MMP value from 0.5 to 0.9 is 0.54. So here we have trained our custom YOLO-V6 model on our dataset. Now let's do the inferencing. For inferencing, we have all these images. So within the test images, we have this number of images. So here we are using this command for inferencing. So here we are putting the weight file that we have created for after training, you can see. And then we are putting the test images directory here as source parameter, and then we are putting the dataset.yaml here. Then this is for the directory where the test result will be saved. So here this will be the directory where we'll be saving the test results. So after running the command here, we'll be getting output like this. So here these are the outputs we have received from our model. So open that, you can see. So this is the tortoise with an 0.9% of of probability. Then we have dolphins. Here you can see 0.83, 0.53. Then we have this guy here, that is 0.9. And then here we have both tortoise and dolphin with an accuracy, with an probability of 0.68 for dolphin and 0.89 for tortoise. And then we have dolphins here, then we have another tortoise here. So guys, these are the results we are getting after training the model for 50 number of epochs only. So to create a robust YOLO-V6 model, I would suggest go for higher number of epochs, for example 300 or 500, and increase the number of images for training. So we can check all these images here also. So if you run this command, it will take the images from this folder and it will show on this notebook. So you can see the same thing. So we have seen how to train a YOLO-V6 model on custom data. I hope this was helpful. Please like, subscribe and share. I'll see you in the next video. Till then, take care.